example, graph the point -5, 3 pi over 4. So if I give you a point in polar coordinates, remember the first coordinate is your radius and the second coordinate is your angle. How would you go about graphing this bad boy?
Say that again, which one's
So the way polar coordinates works, the first one is your radius, this is r, and the second one is your angle.
okay.
So because my r is 5, well my r is -5, but remember we kind of account for the negative afterward. So since my r is 5, I need to be on a circle of radius 5. So here's something like a circle of radius 5. Enough. Now, 3 pi over 4, that angle is going to start from the polar axis, or the positive x-axis. And the way polar coordinates works is you go out your angle, 3 pi over 4 lands in the second quadrant. And if my radius were positive, this intersection would be my point. But since my radius is negative, I have to go in the exact opposite direction. My point actually ends up down in the fourth quadrant. What do you think? Remember that? It's okay, relatively straightforward. Multiple representations. Okay. So one of the tricky things about polar coordinates, I kind of left off with this last time, is there are multiple ways to write a single point. So if you look at this example here, I give you the point 2 comma pi over 6. And I ask you for different representations of this point. I say find 3 different representations of the point satisfying the following conditions. So I want you to give me different ways of writing the same exact point, but I want r to be less than 0 and theta greater than 0. Right? R greater than 0, theta less than 0, etc. First of all, where does this point land? How do I graph this point? First quadrant, radius 2. Well, that's easier than 5, I can do that. Radius 2. Check out this circle. Oh, it's so circular. All right, so circle, radius of 2, pi over 6. Here's my polar axis. Here's pi over 6. Look, it's Pac-Man. Just kidding, it's not Pac-Man, it's a circle, stop laughing. So, there's my pi over 6. Here's my point, A. I want to be able to draw this, or to write this A point with different coordinates, which have r negative and theta positive. So how can I represent this point with r negative and theta positive? Yeah, so the fact that r is negative, well, okay, that gives me -2 for my r coordinate. And then to figure out the theta coordinate, you basically have to figure out which angle would land you in the direct opposite direction, in the exactly opposite direction. If you figure out which angle lands you here, then the negative radius will flip you back up.
7 pi over 6.
7 pi over 6. So if we went out to 7 pi over 6, 7 pi over 6 for my theta, the -2 radius would then flip me back into the first quadrant. What if I want r positive but theta negative? That's the second one. R greater than 0, theta less than 0. So 2 is my radius since r is positive, but the difference for theta being negative means I have to go down first, right? I have to go clockwise. So I have to find this angle here, which is what? Negative 11 pi over 6. Right, it's almost 2 pi. It's almost 12 pi over 6. Negative 12 pi over 6, but not quite. Okay. And then, yes, both angles negative. Or not both angles, both coordinates negative. So negative 2, and then also a negative angle. So when your radius is negative, you always want to land in the exact opposite quadrant, exact opposite direction. But since my theta is also negative, I'm going to have to go this way. So instead of 7 pi over 6, what do you think I should use? Negative 5 pi over 6. So you guys are so good at graphing angles that this is easy.
So good.
I know, right? Trained you well. I'm sure there's probably, oh, this should be free. I'm sure there's probably formulas or something you can use for this, but if you want to find different representations and just graph it and think about it would be my advice. That's my advice for almost every math problem. Graph it and think about it. But remember what I said at the end of last class, no matter what point I give you, you can always find a representation that has a positive radius and an angle that's less than 2 pi. And in fact, you can always find exactly one representation except at the pole. Right? The pole has an infinite number of representations. The pole is going to be 0, anything. But every other point has only one representation for r positive and theta less than 2 pi. So, one of our goals in learning polar coordinates is to be able to graph. And sometimes it turns out that equations in rectangular coordinates, equations with xy coordinates, are easier to graph if you have r theta. So we talked about for a little bit converting between rectangular and polar. There's an error up there. I keep forgetting to correct it. It's only 3 semesters I haven't corrected that error.
Right on your hand right now.
I know, right? I should just carve it into my skin. Oh, I'm super hardcore about things. So, let me talk about what these formulas mean here. So remember, what I want to be able to do at this point in the game, what I'm trying to be able to do is go between r theta coordinates and xy coordinates. And so for example, if I give you an r theta, so basically I've given you this radius, right? I know the radius. So the radius is known. And also the angle is known. I want to be able to reconstruct the corresponding xy coordinates. So basically I want to be able to find how far I would have to go out this direction, which would be my x coordinate, and how far I'd have to go up, which would be my y coordinate. Not coincidentally, this gives me a right triangle. So I should be able to use some trig arguments to set up equations that relate r and theta to x and y. So say I wanted to solve for y. What trig equation could I set up? Whoa, x squared minus r squared. So I know r and I know theta. So what trig function relates theta, r, and y?
Is it y equals r times sine?
Yeah, good job. It's an excellent reading ability. So, sine theta is y over r. That's just what we've known for our entire trig logic. And so if you multiply up the r, you get y equals r sine theta. So what this does, if you know r and you know theta, you can solve for y. You can go back and get your y. To go back and get your x, you set up a cosine argument. Cos theta equals x over r. So if you multiply up the r, x equals r cos theta. So these are kind of important polar coordinates. To get back to y and x, y is our sine theta, x is our cos theta. The other way is where the other two equations come from. If I know instead x and y, so it's the same picture, except now I know my xy coordinate. Right? I know how far I went this way, and I know how far I went up. And I want to figure out how far my radius is, right? How far I go from the origin to the point. So I want to figure out r, and I also want to figure out theta. So let's start with r, because that's the easiest. What relates x, y, and r?
X squared plus y.
Pythagorean theorem. Right triangle, if you know the two legs and you want the hypotenuse, use the Pythagorean theorem. So that'll solve for r. What about theta? What relates theta? You can use tangent. Now this is where my mistake is. Tan theta should equal opposite over adjacent, or y over x. Put x over y up there. So to convert between polar and rectangular, these are your four formulas. I won't give you these, okay, so if you want to use them, you have to know them. They're not super difficult to derive because they're just all of your trig definitions, okay? And then the Pythagorean theorem. But if you're good at memorizing things, I guess you can memorize. Do some quick examples here. So convert from polar to rectangular. -2, -3 pi over 4 is my polar point. R theta. R theta. And I want to know what my corresponding x, y are. You could draw a picture and think. That's my normal advice. But in this case, you can actually just plug it in the formula. It's not super mind bending. Right? X is forever and always r cos theta. And y is forever and always r sine theta. So if you have r and you have theta, you have x and y. So for x, I would plug in exactly what I see. -2 times cos -3 pi over 4. And then I just evaluate. What's cosine of -3 pi over 4? Okay. Cool. I'm starting to feel like I've done my job. Yeah, some kind of root 2 over 2, right? So the question is really about the sign. You know that -3 pi over 4 is going to end up in the third quadrant, right? Because you have to start from here and go back this way, since it's a negative angle. So this guy will be -√2 over 2, -√2 over 2. So for cosine of -3 pi over 4, I'm going to put in -√2 over 2. I have my radius hanging out still. Then if I cancel my denominators and change it to a positive, I have my x coordinate. So the 2's cancel, becomes positive, x is root 2. What's y? Same thing. Absolutely same thing. Y. WHY. When you plug it in the formula, you're going to have r sine theta. But because my angle is negative 3 pi over 4, sine theta is the same exact thing. Right? This will be negative 2 times negative root 2 over 2. The 2's cancel. And it becomes positive. So whether I graph this in polar by going to a circle of radius 2, an angle of negative 3 pi over 4 and flipping, or if I go out root 2 on the x and root 2 on the y, I should get the same point. Question? So far so good? So my polar point, or I'm sorry, my rectangular point here would be root 2. Does it make sense if this is in the first quadrant? Would you land in the first quadrant if you graph this?
Yes.
Sure, right? Because negative 3 pi over 4 lands here, and then you flip it back. Well, I'm convinced that we did it right. So what happens here? 1, 2 radians.
31.
Yes.
Where'd you get the, this is probably from last time.
Okay.
Where'd you get the x equals r cosine theta and the y equals r sine theta?
That's the formula.
That's the formula we learned earlier?
That's the one we just wrote up there. Yeah, that's
Oh, I see it now. I didn't copy down the second.
Yeah.
That's probably bad.
Yeah. Okay, so for this one, x and y will be the same thing. I mean, the formula is always the same. What's the only difference here? Yeah, this is too bad for you guys. You just don't have a pi. Right? So x is 1 times cos 2, and y is 1 times sine 2.
Isn't the pi always implied though?
No.
That's how it was.
Just like you asked me before, no.
No.
What's pi over 2 if you don't want the pi? 1.57 radians. So whether you write it as 1.57 radians or you write it as pi over 2, it's the same thing. So this is not 2 pi radians. So if you wanted to get an approximation, you'd have to plug this in your calculator. Someone want to get that for me?
Negative 0.4161.
Negative 0.4161.
Does it matter for degrees?
It does. What did you get? Were you in radians?
I was not.
You were not. Okay.
Okay.
What's sine of 2?
0.9092.
0.9092?
Yeah, 93.
Not 3. Very important.
Yeah.
Yeah, no way. Our shuttle would crash. So my point here would be negative 0.4161, comma 0.9093. Easy enough? You should be hoping that I give you point conversion in your final exam. But I won't. Too easy. might give you equation conversions. We'll do in a second. So literally in this situation, it's just plugging into the formula. Going back the other way is a little trickier. Not that much, a little bit. So convert from rectangular to polar. So I'm going the other direction now. From rectangular to polar. Alrighty. Negative 2 root 3 comma 2 is my rectangular point. So since this is in rectangular, what that means is I'm giving you x and I'm giving you y. And I want to go back, or I want to convert to r and theta. So which equation do you think I should use here? It doesn't make any sense to use these anymore, right? Because if you plug in y equals 2, you have two variables on the other side and you won't be able to solve. Right? So maybe go up and use the top two formulas. X squared plus y squared equals r squared is a crowd favorite. We can figure out the radius of this really quickly, the radius of this point, by using the Pythagorean theorem. So r squared is going to equal negative 2 root 3 squared plus 2 squared. Oh, what's negative 2 root 3 squared? So you're going to square the 2, which becomes 4, and you're going to square the root 3, which becomes 3. So 4 times 3 is 12, plus 4, so r squared is 16, r is 4. Now this is, hopefully that was clear. A little tricky here. So now how would I solve for theta? I have r, I want theta. Yeah, since I have r, you can use a lot of equations. Let's stick with tangent. Right, tangent of theta is this is a lie, this is lying to you. Tangent of theta, it's making me angry that it's lying to us. Tangent of theta is y over x. So let's try that, because I have y and I have x, so I should be able to solve for theta. So tangent of theta is 2, because y is 2, over negative 2 root 3. Or if you simplify, negative 1 over root 3. And if you rationalize, to make it look more like something you're used to seeing, negative root 3 over 3. So your goal would be to determine theta, given that tangent is negative root 3 over 3. Unfortunately, there's two places where tangent is negative root 3 over 3. Tangent is negative in the second and the fourth, right? So down here, it's going to be negative root 3 over 3. And up here, it's going to be negative root 3 over 3. Right, if you remember the way tangent works, it increases as you go up the circle. Right, root 3 over 3, then 1, then root 3. So the smaller reference angle is the root 3 over 3. But which quadrant am I going to pick? Second? Why second? Because x is negative, y is positive. From your original point. From your original point, you know x has to be negative, y has to be positive. So you have to go this way and then this way. Negative 2 root 3, root 3. point must be in quadrant 2. Which means my answer for theta here would be what? 5 pi over 6.
I missed why you said it's in quadrant 2.
If you graph this point, you have to go negative on the x-axis, which is this way, and then positive, should be 2, and then positive on the y-axis. So because x is negative and y is positive, you have to be in quadrant 2. So my point altogether is 4, 5. Once you have r, right, once you solve for r, then because you have r, x, and y, you can really use any of these equations. Right, you don't have to use tangent if you don't like tangent. If you're better with sine, use sine. What would I have set up if I wanted to use sine instead of tangent here?
2, 4, 4.
So sine of theta equals y over r. So sine of theta equals y is 2, r is 4. So I could have solved sine of theta equals 1/2 instead. I'd still have to make sure I was in the second quadrant, but I should get the same answer. All right, so once you have r, you can really use any trig function you want. Yay! Awesome example, John. The best teacher ever. I love going to class and I love my life because of you. Questions? Yes. Well, I was saying that instead of using tangent, because some people don't know tangent as well, like they don't know the tangent values. So instead of using tangent, you can set up sine, and you'll just use this equation, the same equation that is always true for sine. Right, sine is always equal to y over r. So I plugged in y equals 2 from the point, and r equals 4 from my first circle thing. And then from here, if you solve for theta, you'll get 5 pi over 6. So it's another way to do this thing. What about 0, -6? Convert from rectangular to polar.
So we should find r.
Sure, you can find r. Find r. Where you are. Come home.
So Pythagorean pyramid?
Yeah. Right, we're given a rectangular point. So this is x. This is y. So I know that r squared is going to have to equal 0 squared plus -6 squared. R squared equals 36. R equals 6.
So now we can use anything because we found r.
Now you can use anything. What do you want to use? What happens, by the way, if you use tangent? Oh. Right, tangent's y over x, so you would get tan theta equals -6 over 0. So tan theta is undefined. So maybe that freaks you out. Maybe that's like making you really nervous and you can't handle that right now. So let's try sine instead. What would sine theta be? Y over r. So sine theta equals negative 6 over 6. Sine theta equals negative 1. And then I turn to my unit circle. Hello, trusty unit circle. Where is sine negative 1 down at the bottom here? So what angle should this be? 3 pi over 2. Boom.
Stuff right there.
That's amazing stuff. So in polar, this is your point. Now, in my opinion, I just severely wasted your time. Because using these formulas for something so simple as 0, negative 6 is just a waste of time. I mean, if you graph 0, negative 6, like in x, y coordinates, 0, negative 6, 1, 2, 3, 4, 5, 6, you can just convert this to polar without doing any trig at all. I mean, it's got to be an angle of 3 pi over 2. And your radius, since you went 6 units down, your radius has to equal 6. Done. But if you don't like to draw pictures and think, you have formulas.
So whenever I have a nice number like 0 or 1.
Yeah, when it lands on an axis, right? If it's a 0 here or a 0 here, you can just draw it and find it pretty easy. All right, so more to the point, more than converting single points from polar to rectangular or vice versa, we want to be able to convert entire equations. So sometimes an equation in x, y coordinates will be very simple, but in polar coordinates it'll be very complicated. Or it'll be very complicated in x, y, but very simple in polar. So it's good to be able to go between them, just to help you graph things more easily. So let's start with part A there. I want to convert this equation from x, y variables to polar variables. So I want to get r theta in. You use all the same formulas. You're given this equation, 2x minus 3y equals 4. And it says convert each rectangular equation to a polar equation. So I want to convert my x's and y's to r's and theta. Let me write down the 4 things that I know in the entire world. X squared plus y squared equals r squared. Tan theta equals y over x. Y equals r sine theta. X equals r cos theta. These are my polar formulas. All I know. And I want to trade in my x for an r and a theta. Trade in my y for an r and a theta. What can I do? X is equal to r cos theta, right? I don't want x, I want r and theta. So replace this x with r cos theta. Replace this y with r sine theta. Because that's what they use. So my equation in polar becomes 2 times r cos theta minus 3 times r sine theta equals 4. The instructions actually tell you to solve the polar equation for r. So one part of my job is done. I've traded in the x's and y's for r's and thetas. But kind of like how we like to have y isolated, we like to have r isolated in polar equations. So how can I manipulate this to have r isolated? There's an r in each factor, or there's an r in each term, so I can factor it out like this. Excuse me. And then since these are connected by multiplication, I can divide to isolate r. So this is my polar. Now, first of all, questions on how I got that? No, easy.
Make sense?
Replace x and y with r sine theta, or with r cos theta and r sine theta. That's really all we did. Then we solve for r. The more analytical question, which one's more complicated? Which one do you like more?
The first one?
The first one. I like the first one more as well. What is the first equation if I graphed it? You know? If you solve this for y, what do you get? Negative 3y equals negative 2x plus 4. Divide by negative 3. Y equals 2/3 x minus 4/3. So I solve for y. What does this look like? It's a line. Line. Can't get any simpler, right? Simplest function in the world, line. You can graph it, slope, y-intercept, easy. You convert it to polar, all of a sudden we have variables in the denominator, so it looks like we have some sort of asymptote or some craziness going on. So by converting a line to polar coordinates, you made the equation harder to graph. Which makes sense because lines are more rectangular, right? I would think. Well, let's try part B here. X squared plus y squared equals 9. So there's an easy way and a hard way to do this. Let's do the easy way. So if you're comfortable following a process, you would come over here and you would put r cos theta in for x and r sine theta in for y. And you would be right. There's nothing wrong with it. But maybe there's another formula up here we can use instead. R squared is equal to x squared plus y squared. So instead of doing r cos theta and r sine theta, we can skip a step, or 2 or 3, and replace x squared plus y squared with r squared. So this equation here is just r squared equals 9. Or if you square root, r equals 3.
I like that one.
So this one's a little simpler now. Although we do know we did a little bit of work in 126 at some point in time, and we did learn how to graph this. Do you know what this is? Circle. Radius 3, center 0, 0. So this guy here is the standard form for a circle. In rectangular, it's kind of complicated. It's got an x squared and a y squared, right? But in polar, it's just r equals 3. It's very explicit. This is a circle of radius 3. Done. So lines become a little bit more complicated in polar. Circles become a lot more simple. Let's go the other way. Convert each polar equation to a rectangular equation. So convert from polar to rectangular. Theta equals 5 pi over 6. first polar equation. The only thing I know in the world is that x squared plus y squared equals r squared, tan theta equals y over x, and then y equals r sine theta, and x equals r cos theta. This is what I know as far as converting goes. So what do you think, math slaves? Yeah, so we can actually use this tangent formula if we're clever. Right? We can get a tangent theta into our equation by taking the tangent on both sides. So you're going to have to manipulate this to make it look more like this by doing tangent on both sides. Right, so as long as you do it to both sides of the equation, it's not going to change anything. So you put tan theta here, or tangent on this side, tangent on this side. That's getting us closer to this equation, which will let us go to xy eventually. Now tan theta is basically a variable. I can't do anything with it. It's a variable quantity. But tangent of 5 pi over 6, I know. Tangent of 5 pi over 6. Negative root 3 over 3, right? 5 pi over 6 is out here, and the tangent is negative root 3 over 3. So I replace it. Okay, what's that mean? Well, okay. How about instead of tan theta, yeah, so, well, kind of. But instead of tan theta, y is a variable. It's not one constant value. Right? So you don't want to say y equals negative root 3 and x equals 3, because that's not really the situation. But you do know that tangent is y over x. Right? So you can substitute. Tan theta equals y over x. So you put that in place of tan theta. And then if you multiply up your x, here's your equation. What's this equation? What's this look like? It's a line, it's another line. Oh, how come you guys aren't all saying that?
I was thinking it.
Is that, oh, you're thinking, oh, sorry. I haven't worked on my mind reading ability today. So this is a line again. But the polar form of this line is a little bit simpler than last time. So how come you think this one is simpler than the line we had in the last example?
It's only one.
Well, yeah, no, it's simpler because there's one variable, yeah, but what is it about the line that makes this simpler form here? What's the y-intercept? 0. So lines that go through the origin actually have a pretty simple polar form. Right? Because lines that go through the origin can just be described by their angle. The angle that they make with the polar axis. But if you have another line, if you shift this line up at all, that's annoying to write in polar. Right, so if you shift it up or down at all, it'll be annoying in polar, but if it goes right through the origin, it has a pretty simple polar form. It has a pretty simple rectangular form too. So whatever. But there's going the other way. When you have this, one of the tricks, if you just have theta by itself, you can take tangent on both sides. One trick. There's a lot of different tricks you might have to figure out. What about this guy? 4 sine theta equals r. I started in r theta, I'm starting in polar, and I want to end in rectangular xy. What do you think? So, there's a couple ways to look at this, but since I have a sine theta, I'm sort of banking on this using this equation, using this one. Okay? And one way to look at it is, in order to use this equation, I have to have r sine theta, and I only have sine theta. So what you can do is force an r in there by multiplying both sides by r. You don't have an r? Too bad, I'll give you an r. Like that. Take that r. So you put r on both sides, multiplication. On this side, it'll be 4r sine theta. On this side, it'll be r squared. And both of these I can replace. All right, what's r sine theta? Y. That's exactly y. All right, so this guy will become y. And what's r squared? X squared plus y squared. So 4y equals x squared plus y. Now, I've converted to rectangular. This is rectangular. It's got all x and y. I didn't ask you to graph the equation. Oh, I did ask you to graph the equation. Oh man, I'm awesome. All right, totally predicted what I wanted to do. So, I actually don't, this doesn't tell me as much because I'm not sure what this equation looks like yet. So do you know how you might get a graph of this? It's probably going to be a circle because it's got an x squared and a y squared. Right, so as soon as you see x squared plus y squared, you're thinking circle. Right, but you're going to need to get it equal, to get it in the right form. Right, x squared, here's the standard form for the equation of a circle. Right, so the equation of a circle looks like x minus h squared plus y minus k squared equals r squared. If you have this equation, then you know that you have a circle of radius r and center hk. R, center, so this is from the class, or class course 126. Yeah. So how can I manipulate this equation to put it in this form? Let's get, one thing that I know about this equation is that it has all my x's and y's on one side and then constants on the other. So I'm going to move my 4y over with my y squared. So to graph this, I have to subtract the 4y over. And so if I subtract this guy, I'll have 0 on one side, and x squared plus y squared minus 4y on the other side. But it's still not what I want, because I actually want y involved in this quantity squared. So there's a trick you can use to write this as a square quantity. Remember what it's called?
Completing the square.
Completing the square, that's better. Completing the square. Right, you can add a magic number right next to the 4y so that it becomes a perfect square trinomial. Remember what you add? Yeah, it's 4, okay.
Double that.
So you add whatever you need to make this factor down nicely, but the way the formula says, you take half of the number in front of the y, half of b, and then square. Or b over 2 squared. So you take half of negative 4, which is negative 2, and you square it, which is 4 again. But if you add 4 to one side of an equation, you have to add it to the other side or else you changed it. So you have to make sure you put the plus 4 on both sides. So this is where I'm at. How does this factor? Or what's this break down to? Y minus 2 times y minus 2. Right? This guy factors into y minus 2 squared. Holy moly, all right. So now it's in the perfect form. So what's that mean? Can I graph this now? What's my radius? 2, because the radius squared is 4, so r equals 2. Cool. What's my center? 0, 2. Right, the center comes from what's being added or subtracted to the x and the y. Nothing's being added to the x. So 0 is your x coordinate of the center. 2 is being subtracted from the y, you change the sign. And then you know your graph. Center 0, 2. Radius 2, so I go out 2 in every direction. 1, 2, 1, 2, 1, 2, 1, 2. Here?
Yeah.
So the formula for completing the square says that you take half. So what I did is I took half of the middle number. So what's half of negative 4? I did half of negative 4, and then I squared it. So half of negative 4 is negative 2. When you square it. So that's the formula for completing the square.
I didn't like that one as much.
Yeah. So here's the thing. It kind of sucks to be given a pretty simple equation, convert it to rectangular, do all this algebra, and then get your graph. Like there's a bunch of crap to do. Right? So what we would rather be able to do is just take this equation and plot it right in Polar without going to rectangular and doing all the algebra. Right? So the last part of this section, or the last part of these notes here, is to plot some equations in Polar without converting to rectangular. So I gave you a nice little, I stole this from the book, but I gave you a nice little diagram here showing you what different polar equations look like. So for example, anytime you have this format where r is equal to a number times sine theta, this is going to end up being a circle on the y-axis. Right? It's going to end up being this guy over here. And then, you know, if you go down, you get these shapes, limacons, cardioids. So these look a little different. You have to have an equation that's like a number plus a number times sine theta, right? A number plus a number times cos theta. So we'll do one of those. You don't have to memorize these. I'm just kind of showing you what to expect. And then you can also get out roses, right, and flowers. And these guys look like the flowers have to have a multiple angle. So if you have cosine of 2 theta, or cosine of 3 theta, or cosine of 4 theta, you get a flower. So I wanted to plot a couple of these. So I did one from each class with each class of graphs. Okay, this is the first class I showed you the circles. This is the second class, the hearts, or the cardioids. And then the third class, the third example is the rose. to plot in polar coordinates, you don't want to convert, right? We're kind of trying to avoid conversion. We just want to take this as a polar equation and plug in points and see if we can figure out the pattern. Graph each equation. A r equals 4 cos theta. Here's my advice. Okay? When you're plotting in polar, try to make it as easy on yourself as possible. So for example, I'm a lazy man, all right? If I were plotting this right now, you have to pick theta values and figure out r values, just like an xy table. Right? Theta is your independent variable, that's the thing you plug in, and r is what pops out. Okay? So you pick thetas and you get out r's. To start with, try very simple thetas. Maybe these will be good enough. Maybe you'll be able to find the pattern of these. If these are good enough, fine, you're done. If not, then you have to fill in something in between. But let's see what happens if we start with these. Why did I pick these, by the way? What's special about these? They're on your axes, right? 0 is on the x-axis, pi over 2 is on the y-axis. So I picked really easy things to evaluate sine and cosine on here. So now I have to plug each of these into the formula. So when theta is 0, what's cosine 0? No, 1. Cosine of 0 is 1. Oh, I guess we're going to need to unit circle, here, here, here. We'll make our evaluation. So cosine of 0 is 1, but then I multiply it by 4, so this becomes 4. Cosine of pi over 2 is 0, so I multiply it by 4 and I get 0. Cosine of pi is -1, so I get -4. 3 pi over 2 is 0. 2 pi is 4. Now, huh?
Isn't it?
What'd you say?
Looks like a pattern.
Oh, it is. Oh, absolutely. Absolutely. Let me plot these points and show you why this isn't quite going to do it for me. Why don't I have to go past 2 pi? It's going to start to repeat, right? I mean, it's periodic. Cosine starts to repeat after 2 pi. So what happens here? Where am I going to plot 0, 4? How does this work? So radius 4 means I go to a circle of radius 4, and my angle is 0. So here's my circle of radius 4. Since my angle is 0, I don't go anywhere, meaning my point is right here. That's usually r theta is the way you write polar coordinates. Even though you plug in thetas to get r's, you still write r first. So that's r theta, 4, 0. What about when theta is pi over 2 and r is 0? Where's that going to be at? Origin, right? Here's pi over 2, but I don't go anywhere for my radius. Okay, then what about pi -4, or -4 comma pi? So I'll go out to here's my angle pi, but what's the -4 going to do? Flip it over. So where's it land? Back here. Oh, that's not good. And where does this guy land? Oh, yeah, well this guy lands in the same spot, and this guy lands in the other spot, right? If you go to 3 pi over 2, 0, you get back here. So this isn't quite enough to give me a good picture. So what could I add in between here? You can add anything you want, right? But I would probably add pi over 3 in between because the cosine of pi over 3 is what? It's 1/2. So if you put in pi over 3 here, you can fill in your picture a little bit. And then what can you put in between pi over 2 and pi? 2 pi over 3. So if you put pi over 3 into cosine, you get out 1/2. And if you multiply that by 4, you get out 2. If you put 2 pi over 3 in, what do you get out? What's cosine of 2 pi over 3? Negative 1/2 times 4, negative 2. So let me add these guys onto my graph. How would I graph pi over 3, angle of pi over 3, radius of 2? So here's your radius of 2. But I have to have an angle of pi over 3. So it will go right here. What about 2 pi over 3 negative 2? Well, here's 2 pi over 3. But because it's negative 2, it gets flipped. So now we're getting a little better picture. What do you think this is? So one helpful thing to remember when you're graphing these polar equations is if it falls into one of the known classes, right, if it looks like r equals a number times cos theta or r equals a number times sine theta, this will always be a circle, always and forever. So all you have to do is plot enough points to figure out where the circle is. So I'll do the other two types next week.